The Pacific Northwest looks peaceful. Waves breaking, gulls gliding for soup.
20 to 6 miles offshore, the Juan de Fuca Plate dives beneath North America at about 2 inches per year. It's been more than 320 years since Cascadia last broke. January 26, 1700. Every year, motion continues. Energy piles up like a coiled spring, stretching 600 miles of crust under constant tension. At depths between 10 and 20 miles, the plates grind but refuse to slip, an immense locked interface under unbearable pressure. The outer shelf arches upward, pushing the ocean above it. Each inch adds stress, a countdown written in rock. When the grip finally fails, the fault gives way, slipping nearly 60 feet in under 90 seconds. Shock waves race outward at nearly 7 miles per second, shaking cities from Vancouver to San Francisco. Miles of ocean floor jerk upward, an entire section of crust suddenly reborn 6 feet higher. Billions of tons of seawater are shoved toward the surface. The ocean's pulse becomes a moving wall. From above, it's barely visible, a rising dome spreading for hundreds of miles. The total energy equals more than 400 million tons of TNT, 10 times the 2011 Japan quake. Within 15 minutes, pressure waves cover 1,000 miles. The ocean itself becomes the messenger. Dart buoys anchored deep in the Pacific detect the signal, a pressure surge no weather system could cause. Within 15 minutes, the Pacific warning system lights up proof. A continent is on watch. 1,000 miles offshore, a silent pulse races through the deep Pacific, moving at jet speed, unseen by human eyes. In deep water, tsunami speed depends only on depth. The deeper the ocean, the faster the wave. Beneath the calm surface, trillions of water molecules move in slow circles, transferring force across an entire ocean column. As the pulse spreads, its waves cross and combine, amplifying in some regions, canceling in others. When the wave meets seamounts thousands of feet tall, its path bends and focuses, nature's lens shaping raw energy. After just 30 minutes, the wavefront stretches nearly 1,000 miles across, still traveling faster than a jetliner. Even as height falls, the total energy remains. Like a tide compressed in motion, momentum never fades. The North Pacific Gyre redirects part of the wave toward Hawaii and Alaska, a transoceanic relay of power. From space, satellites detect a rise no taller than 3 inches, yet it holds the mass of entire mountain ranges. Deep ocean sensors confirm the signal, a periodic pressure rise only instruments can feel. As the wave meets the Aleutian Islands, energy refracts and splits. One branch arcs toward Alaska, another toward Hawaii. Pressure waves travel through the deep at near-sonic speed. Their rumble detectable 2,000 miles away. At 20 hertz, the ocean itself hums, a sound so low it can circle the globe twice before fading. On the surface, it's nothing, a gentle swell rising less than a foot. Yet beneath lies the energy to flood a coast. After an hour, the wave spans the entire ocean, from Japan to Alaska, from Kamchatka to California.
3 hours after the quake, the wavefront has crossed 2,000 miles, its energy still intact, its direction unchanged.
In Honolulu, analysts run real-time models, each line of code representing millions of lives along the Pacific Rim.
Forecast models show Hawaii at 4 hours, Alaska in 5, California 6.5. The countdown has begun.
Alaska's steep continental shelf turns the wave into a rising wall, focusing energy toward Kodiak and Prince William Sound. As the wave slows from 450 to 60 miles per hour, its energy has nowhere to go but up. 4 hours later, the first sign appears, the ocean pulling away from the shore, exposing reefs that haven't seen air in centuries.
NOAA issues a tsunami warning for the entire Hawaiian archipelago. Every second now counts.
Model projections show wave heights of 25 to 35 feet along northern Oahu, a once-in-a-lifetime event. As the wave meets Hawaii's shelf, speed drops to 50 miles per hour. Energy compresses vertically into a tower of water. Pressure builds to over 400 psi along the shelf edge, the ocean's own hydraulic hammer. A dark horizon forms. The first crest now rises nearly 200 feet above open water.
500 miles north, Alaska's coast receives its own warning found. Models predict run-up heights over 150 feet in inlets.
6 hours after the quake, the continental United States waits. From San Francisco to Seattle, harbors prepare for the unthinkable. The Pacific's energy focuses again to Merwind, reflected by undersea ridges, amplified by bays and channels. By the 7th hour, the wave towers close to 1,000 feet off the continental slope, a theoretical limit of nature itself. At 6:12 p.m. local time, the horizon itself begins to lift, a moving wall of water, almost beyond scale. As the seabed shallows from 3,000 to 300 feet, the wave slows to 50 miles per hour and rises more than 3 times higher. What was once speed becomes height. Kinetic energy turns to potential, trading motion for mass. As the first crest passes the reef shelf, it towers over 250 feet, translucent. At its base, pressure exceeds 500 psi, enough to crush submersibles and shift coral rock. Computer models predict a run-up of over 200 feet along northern Oahu, flooding valleys unseen by ocean in 10,000 years. The withdrawal is just as violent. Millions of gallons pulled seaward, dragging everything not anchored to bedrock. Then comes the second wave, smaller in height, greater in force, pressure layers stacking like dominoes. Far north, Alaska's steep fjords act as funnels, focusing the tsunami into narrow bays, multiplying its reach. Reflected waves meet incoming crests, amplifying through resonance, a collision of pure momentum. By the 7th hour, the wave reaches the continental shelf, the last obstacle before the American mainland. Monterey Bay acts like a natural amplifier. Its deep canyon turns the approaching swell into a hammer. In simulation, water overruns low-lying ground, moving at 35 miles per hour turtle, pressure exceeding 10 tons per square foot. Within minutes, resistance from land and friction drains momentum, each pulse weaker, but still vast. Reflected energy crosses back toward Japan and New Zealand, a reminder that no coast stands alone. Even the atmosphere feels it. Air pressure ripples circle the globe in less than 36 hours. After the main event, a smaller aftershock shakes the same fault grid, stress redistributing like a tightening seam. By midnight, the ocean quiets again, carrying the memory of one of Earth's most powerful movements. Across research centers, terabytes of data pour in, capturing the full anatomy of a mega-tsunami for the first time. It's not destruction that defines this event. It's data, discovery, and the realization that oceans never sleep. Hours after the waves have passed, the Pacific lies still again, vast, quiet, and changed. Beneath that stillness, the seafloor tells a new story. Ridges raised, valleys collapsed, energy spent. From satellites to seafloor sensors, terabytes of data stream home, a digital echo of the ocean's pulse. Within hours, models replay the event, allowing scientists to see what no human eye ever could. The event released more energy than the largest hurricanes combined asserted, yet it was driven by silence, not storm. In the days after, the ocean begins to settle. Sediment drifts, reefs recover, and the data keeps flowing. Every drop of seawater remembers motion, a record written in currents, salinity, and temperature. From Tokyo to Seattle, from Alaska to Chile, one ocean connects them all. What happens in one trench touches every shore. Every event teaches. Every dataset refined the models. And every warning buys time for the next generation. Preparedness isn't fear, it's science in motion. Detection, warning, evacuation, education, a cycle that saves lives. The ocean is neither friend nor enemy. It is a system, vast, living, and ruled by physics, not emotion. From orbit, our planet looks peaceful, a fragile sphere sustained by the same forces that test its strength. The 2025 Cascadia event isn't just a model, it's a message. Science warns not to scare, but to prepare.
Produced by Storm-SP, where science meets cinema.
Knowledge saves lives. Share it, teach it, and prepare. The next wave begins with awareness.